Elon Musk has recently ended his silence regarding three ISATs, delivering a stark warning about a possible collision path that has created ripples of concern throughout the scientific world and across global social media platforms. Through a sequence of rapidly viral posts, Musk, who maintains access to SpaceX's sophisticated tracking infrastructure and maintains direct channels with NASA, disclosed information that the space organization has not publicly confirmed. The trajectory of Atlas has undergone modification. Based on Musk's computations derived from SpaceX monitoring information, the enigmatic interstellar entity no longer follows a secure flyby route. Its current path brings it perilously near to Earth's orbital trajectory, with a window for potential impact emerging in roughly 28 days. Musk expressed himself with directness and clarity. The likelihood of collision exists and continues to grow. NASA possesses this knowledge. Their reluctance to share stems from concerns about triggering widespread fear, yet citizens have a right to understand what approaches. His subsequent communication included SpaceX monitoring information demonstrating Atlas executing methodical trajectory modifications that have shifted its course by vast distances. These adjustments have incrementally positioned it nearer to a direct intersection with our planet. What amplifies the severity of Musk's caution particularly involves more than merely sounding an alert. He has declared that SpaceX already pursues emergency contingency plans, encompassing possible expeditions to modify Atlas's course or implement protective mechanisms. When an individual who literally constructs spacecraft professionally begins discussing planetary protection in actual time, attention becomes imperative. Before examining Musk's trajectory evaluation and NASA's reluctance to validate his concerns, consider subscribing and engaging with this content, because the forthcoming information about Atlas's collision path will fundamentally transform your perspective on the approaching 4 weeks. Musk has faced accusations of alarmism previously. However, when he issues warnings regarding collision paths, utilizing his proprietary monitoring information supported by SpaceX technical specialists, dismissing it as sensationalism becomes irresponsible. Let us investigate precisely what Elon Musk disclosed concerning Atlas's trajectory, because the particulars prove both comprehensive and profoundly disturbing. According to information Musk distributed from SpaceX's monitoring network, Atlas has executed 23 separate trajectory modifications throughout the preceding 6 weeks. Each modification involved minor adjustments, velocity alterations of several hundred miles hourly, directional shifts of several degrees. Yet collectively, these modifications have transported Atlas from a secure flyby route to one that crosses Earth's orbital region. Musk published comprehensive orbital mechanics computations demonstrating Atlas's initial trajectory would have carried it past Earth at approximately 8 million miles separation, substantially beyond any collision danger. However, the combined influence of those 23 maneuvers has diminished that nearest approach measurement to roughly 180,000 miles below the lunar distance. A SpaceX technical specialist involved in the trajectory examination clarified the apprehension. When systematic trajectory modifications progressively diminish closest approach measurements, that pattern doesn't represent random navigation. That constitutes targeting conduct. Atlas steers itself toward Earth through deliberate, calculated movements. The uncertainty involves whether it intends passing by 180,000 miles or if supplementary modifications will position it even nearer. Musk's warning extends beyond merely the nearest approach measurement. He pinpointed a particular time frame, 28 days following his initial caution, where Atlas's anticipated position crosses Earth's orbital trajectory. Should Atlas maintain current trajectory patterns and execute additional velocity modifications, it could position itself directly within Earth's route, with timing suggesting intentional interception. The SpaceX monitoring information reveals Atlas accelerating at precise intervals that optimize gravitational assistance from planetary configurations. This represents sophisticated orbital mechanics, employing planetary gravity for trajectory modification with minimal propellant consumption. This matches exactly what spacecraft mission designers implement when developing efficient paths through our solar system. Musk stressed the targeting accuracy. Atlas comprehends orbital mechanics superior to our understanding. Every modification receives perfect timing and positioning for efficient trajectory alteration. This doesn't represent a comet drifting on momentum. This constitutes a spacecraft implementing a complex navigation pattern, and that pattern directs it toward Earth. The entrepreneur additionally disclosed that SpaceX identified something NASA hasn't publicly acknowledged. Atlas's velocity relative to Earth shows reduction. When objects traverse past planets on hyperbolic trajectories, they gain speed approaching and lose speed departing. However, Atlas demonstrates velocity reductions suggesting active deceleration, as though preparing to synchronize with Earth's orbital velocity rather than passing at interstellar speeds. Musk's examination incorporated probability computations that sparked substantial debate. He evaluated a 12% likelihood of actual Earth impact based on present trajectory and documented maneuvering configurations. While 12% might appear modest, in planetary protection terminology, any probability exceeding 1% receives consideration as exceptionally grave. For perspective, the asteroid Apophis maintained a briefly computed 2.7% impact probability during 2004, and that sufficed for triggering international focus and emergency monitoring protocols. Atlas at 12% constitutes a threat magnitude approximately 4 times more critical. Yet NASA hasn't initiated observable emergency response measures. Musk didn't merely broadcast a warning. He announced that SpaceX already develops response alternatives, and the magnitude of his proposals exposes both the gravity of the danger and the constraints of our protective capabilities. SpaceX has evidently been formulating mission frameworks for rapid deployment spacecraft capable of rendezvous with Atlas and attempting trajectory modification. Musk released preliminary concepts displaying modified Starship spacecraft equipped with mechanisms for either kinetic collision or proximate nuclear explosion, the two fundamental approaches for redirecting incoming entities. The kinetic collision strategy involves propelling a spacecraft into Atlas at high velocity for momentum alteration. NASA successfully proved this methodology with the DART mission. However, Atlas introduces complications that DART's target didn't. It possesses greater magnitude. It travels faster. Most critically, it maneuvers. Striking a stationary asteroid presents difficulty. Striking a spacecraft-sized entity capable of evasion proves exponentially more challenging. A SpaceX mission designer participating in the conceptual development clarified the challenge. We essentially attempt designing a mission for intercepting and deflecting something possessing superior propulsion and maneuverability. It resembles attempting to collide with a fighter aircraft using a slower vehicle. Even achieving proximity, Atlas could simply accelerate or modify course for impact avoidance. The nuclear alternative, detonating a warhead proximate to Atlas for surface material vaporization and thrust creation that diverts it from course, offers more promise, but involves complicated issues. Initially, it demands international authorization for launching nuclear armaments into space, contravening multiple existing agreements. Additionally, we lack knowledge regarding Atlas's composition or its response to nearby nuclear detonation. Musk addressed these difficulties frankly. Treaties receive writing for typical circumstances. This situation lacks normalcy. If we confront an entity on Earth collision trajectory, we employ whatever instruments we possess, irrespective of treaties. Violating space weapons conventions proves preferable to observing a city's obliteration because we worried about documentation. However, the most revolutionary component of Musk's suggestion involves deploying multiple Starship spacecraft for creating a gravity tractor, positioning spacecraft adjacent to Atlas and utilizing their combined gravitational attraction for gradually modifying its trajectory across time. This represents the gentlest deflection approach, but demands weeks of duration and presumes Atlas doesn't resist or neutralize the gravitational influence. SpaceX has apparently performed preliminary mission organization, demonstrating they could initiate the first trajectory modification expedition within 12 to 14 days given authorization. That proves remarkably swift, exploiting Starship's rapid reusability and SpaceX's launch framework. However, 12 to 14 days creates a constrained time frame given Musk's 28-day collision schedule. Nevertheless, a darker understanding of SpaceX's rapid response organization exists. Some evaluators propose Musk utilizes the Atlas circumstances for advancing his Mars settlement objectives by emphasizing human susceptibility and the requirement for backup planetary settlements. Whether his cautions purely concern planetary protection or additionally involve strategic positioning for SpaceX's commercial interests remains under discussion. Musk's public cautions have generated a controversy storm with NASA, exposing profound tensions between commercial space enterprises and traditional governmental organizations regarding information control during potential emergencies. NASA's official reaction to Musk's trajectory cautions has maintained careful wording and notable restraint. NASA continues monitoring Object 3 Atlas utilizing multiple tracking resources. Present trajectory evaluations don't indicate imminent collision danger with Earth. We recommend caution regarding trajectory forecast from non-peer-reviewed origins. That declaration constitutes diplomatic terminology for we believe Musk errs and generates unnecessary alarm. However, notice what NASA doesn't express. They don't supply their proprietary trajectory information. They don't clarify why SpaceX's computations would prove incorrect. They don't discuss the particular course modifications Musk identified. Their reaction proves dismissive without providing substance. A former NASA administrator clarified the agency's predicament. NASA cannot openly dispute Musk without exposing classified monitoring information that might validate some concerns. They issue broad reassurances and hope Musk retreats or public focus shifts elsewhere. However, Musk has not retreated. Instead, he's intensified, distributing more comprehensive monitoring information and challenging NASA for publicly sharing their trajectory models. He's presented this as a transparency matter, asserting the public maintains a right for knowing about potential dangers, regardless of whether that information generates concern. The tension exposes a fundamental inquiry about emergency communication. Who determines what the public should understand? NASA contends that premature cautions based on incomplete information generate more damage than benefit. Musk contends that maintaining people uninformed until response becomes impossible proves unethical and potentially catastrophic. Multiple space researchers have contributed to the discussion, and they're surprisingly split. Some endorse NASA's prudence, observing that Musk maintains a history of dramatic declarations and that SpaceX's monitoring information, while sophisticated, isn't as thorough as NASA's global network. One planetary researcher argued Musk examines monitoring information from SpaceX's limited observation periods and extrapolates trajectories that NASA's more complete information might not validate. He's additionally not an astronomer or a planetary protection specialist. He's an engineer and entrepreneur who's exceptionally skilled at rockets, but may lack depth on trajectory forecasting for complex entities like Atlas. Other researchers have supported Musk's entitlement to distribute his examination. They emphasize that SpaceX's monitoring capabilities prove genuinely advanced, that maintaining multiple independent trajectory evaluations improves overall examination, and that historical evidence demonstrates governmental organizations frequently minimize dangers for avoiding alarm until threats become undeniable. A space policy investigator described the broader consequences. We observe a historic transformation in who manages information about space dangers. For decades, governmental organizations maintained a monopoly on monitoring and evaluating these dangers. Now, private enterprises like SpaceX possess equivalent or occasionally superior capabilities. The previous model of centralized information management dissolves, whether NASA approves or not. To comprehend whether Musk's cautions prove justified or alarmist, we must examine what multiple monitoring sources actually observe regarding Atlas's trajectory. Independent observatories globally have validated that Atlas executes course modifications. The existence of these maneuvers isn't contested. Even NASA's carefully constructed declarations acknowledge orbital variations. The discussion concerns what those modifications signify for collision danger. SpaceX's information displays 23 modifications across 6 weeks, each diminishing closest approach measurement. Independent university observatories have validated at least 18 of those modifications, with others potentially too minimal for detection without SpaceX's sensor precision. So Musk's fundamental assertion that Atlas steers closer to Earth appears factually precise based on observable proof. However, trajectory forecasting becomes exponentially more difficult when the monitored entity possesses propulsion and can modify course. NASA's reluctance for providing definitive trajectory projections might reflect authentic uncertainty rather than misleading. Forecasting where Atlas will exist 28 days forward demand assumptions about future maneuvers, and those assumptions might prove impossible for reliable establishment. An orbital mechanics authority clarified the forecasting difficulty. With asteroids, we compute trajectories based on gravity and momentum, foreseeable forces. With Atlas, we must speculate what the entity will elect doing next. If it maintains current maneuvering configurations, Musk's collision scenario proves plausible.